Today we are going to discuss about a topic called addressing modes. So before going to the addressing modes, we have to see why addressing modes are so important. So all the programs what we are doing till now, we are writing a lot of programs in the microprocessors, and even it is very important for computer architecture also. So we are writing a lot of programs. So in the programs, we write a lot of instructions. Like there are many number of instructions. So the addressing modes are something like if we define manner in which an operand is given in an instruction. What is meant by an operand? Operand is any value on which we are going to operate. So for example, I say add 50H, where 50H is an operand. 50H is an operand. Okay, so this operand can be given in many ways. This operand can be given in many ways. That is, this data which we are going to operate is given in many ways. The first one is directly giving the data in the instruction. Second one is placing the data in the register or storing the data in the memory so that the data will be fetched from the memory. So the first type of addressing mode is immediate addressing mode. In this particular addressing mode, data is given directly in the instruction itself. That is, for example, what does it mean means saying the data given in the directly in the instruction itself says that now the processor fetches the instruction. So and while fetching the instruction, it gets the data directly in the instruction. So it doesn't have to search for the data, first thing. Second one, it doesn't waste the time also. So when I give the data itself in the instruction, there is no need to there is no need for the processor to fetch the instruction, fetch the data from somewhere. Second one is it doesn't waste the time to fetch the data. So the first example that I want to have is the example is move CL comma 55H. So CL register will get the data of 55H. That implies 55H is an 8-bit data, where CL is also an 8-bit data. So 55H is transferred, or if CL will get the data of 8-bit data, where CL is also an 8-bit, so it will get the 8-bit data. We already know there are 4 general purpose registers. There are AX, BX, CX, and DX, where all these general purpose registers AX, BX, CX, DX can have 16 bits of data. And AX is again subdivided into L comma AH, BL comma BH, CL comma CH, DL comma DH. So it's where L, AH, BL, BH, CL, CH, DL, DH are 8-bit registers. So we'll go with one more example saying that I will move a data 3000H into the BX register. So where what I'll say is BX register will be copied up with a data of 3000H. So 3000H can be divided into two parts, that is 30 and 00, where BL contains or BL copies the data 0h into BL, and 30H will be copied into the BH. Therefore, the BX register contains 3000H. So I will take one more example. Like we started up with adding a number. So that number I will be taking add BL comma 25H, where 20 BL has some data already existing, where that BL data, say for example some XXH, will be added up with 25H. This statement gives me that particular result. So the contents of BL will be added up with 25H, and the result, what is that is the result will be stored again into the BL register. So here what is there is I have given the data directly in the instruction. So the instruction will, the data is not somewhere else in the register or somewhere else in the memory. So there is no need to fetch the data from the memory or from the register. It gets copied up. It will add directly to the contents which are available on the BL with the data which is available in the next section so that it saves the time for us. This is the first addressing mode, that is immediate addressing mode. So the second addressing mode is register addressing mode. So the moment I say register addressing mode, it directly says the data is given in the registration. Gives the data, it says where I'm writing the instruction gives the data in the register. Now I'm placing this data in some register called BL. So what I'm doing is I'm placing the data in BL. That data should be copied up into the register called CL. The register called CL. So what does the instruction means? CL gets the value of BL. CL gets the value of BL. So the contents which are there in the BL is copied up into the CL register. One more example, as these are 8 bits, so 8-bit information is copied into the 8-bit CL register. So in the second example, move CX comma BX. So what does this instruction say? Means the contents which are available in BX, the contents which are available in BX, that is 16-bit data is copied into CX register, which is also 16-bit data, 16-bit register, sorry. So the 16-bit data is directly copied into 16-bit register. Clear? So the next one is, I give one more example, that is increment BX. What is meant by increment? The value which is present in the BX is incremented by 1. Incremented by 1. So there is a data which is available in BX, say for example XX. That XX value is, sorry, it is a BX, so XXXX 16-bit data will be incremented by 0, 1H. So when I add this one, that incremented value will be stored again in the BX, that is 16-bit register. So whatever data we are going to have is not given directly in the instruction, but it is given in the register. So we need to fetch the data from the register, and we have to either do a move or add, subtract or increment, whatever it may be, based upon the instruction, uh, do the functionality. So this is the second type of addressing mode. So we'll stop at this particular moment, uh, describing about two different addressing modes. So what is the first addressing mode? The first addressing mode is immediate addressing mode, where the data is directly available in the instruction itself. And the second addressing mode is register addressing mode, where the data is placed in the register and the processor has to fetch the data from the register and do the rest. Okay. So thank you, and we'll again